Hello, welcome all of you. Assalamu alaikum. As we have met earlier in our previous video, myself Mohammad Mubassir, bearing enrollment number GM3146, and my faculty roll number is 20 GGB417. I am a student of BA Honours Geography, 3rd semester, Department of Geography, Faculty of Arts, Aligarh Muslim University. Now, let's start with today's topic. As we have seen in earlier videos that our topic starts with the statistical method in geography. Now let's see the second unit comes under that. The second unit today's is tabulation and descriptive statistics. Now we will understand that what is descriptive and statistics. First of all, we will understand tabulation. The word tabulation comes from the table or tabular, which means data, arranging data. Now tabulation is a systematic and logical representation of numerical data in rows and columns. As we have know, like we have seen, the rows are like this. This is rows and this is like column. We are making rows and columns like this. So tabulation is a systematic and logical representation of numeric data in rows and columns to facilitate and comparison and statistical analysis, or we call it in other words like methods of placing organized data into a tabular form, like simplifying complex data. Tabulation bring out essential features of data or facilitate comparison, facilitate statistical analysis and save space sometimes. Now we will see tabulation. Tabulation may be simple, double or complex depending upon the type of classification. To tabulate information is simply to organize it into a table. Finally, there are many kinds of or types of table. In general, a statistical table have following components. Now see what are the components. Number one, the title. The box head called column captions. The next one is the stub, means row captions. We are writing in a row like this. We are arranging captions in a row like this. And rows are like this, we all know as. And the next one is the body. The next is prefatory notes. And the next one is footnotes. And finally, source note. We will discuss it one by one, that what is title, how we are using this in a statistical table, what is the use of box head, the stub, body, prefatory notes, footnotes and source note. Now we will discuss it one by one. Now see the title. First of all, we will see the title. What is title? How we are using in tabulation. The title is the main heading written in the capital shown. First of all, we are writing the headings as title, capital shown in the top of the table. It must explain contents of the table and throw lights on the table. As whole different parts of the heading can be separated by column, there are full stops in the little. Finally, we see that first of all, we are writing title from here in a rows form. In a rows form like this, we are writing headings, and then from here starting. Now second one is the box head. We call it as a column captions. That what is box head? The vertical heading and subheading of the column are called column capitals. Like after title, we are using column or sub column, like subtitle, subhead. So we are writing that only the first letter on the box head is capital letter and the remaining words must be written in lowercase. It means in a small letter. Like first of all, we are writing the title and the second one is starting the subtitle. Like if you are writing any of the topic like census, so we write census C capital and ENSUS as small case letter. Now comes to the third point, the stub, row captions. What is stub, row caption? How we are using in the table? The horizontal heading and subheading of the row are called row captions, and the space where these rows and headings are written are called stubs. This is the main part of the table which contains the numerical information classified with respect to row and column captions. Now come to next point, that is prefatory notes. Now we will understand that what is prefatory notes, how we are using this in a tabulation. Prefatory notes is a statement given below the title and enclosed in a bracket usually describes the unit of measurement and is called the prefatory notes. Now come to the next point, footnotes. What is footnotes we are seeing here? And how we are using this in a tabulation. These appear immediately below the body of the table, providing additional explanations. It means that we are writing in below of this, in below we are writing here the footnotes. That what we are writing here, that is called footnotes. The next one is source notes. Now see what is source notes and how we are using this. The source notes are given at the end of the table, indicating the source. The information has been we call it as a text from, includes the information about compiling agency, publication, etc. Just we are saying that if you are preparing or making our biostatistics tabulation of data parts of table or anything we take it, then we are using this. Now we will see, now I will show how to make a tabulation board and how we are using this all in that box, how we are using this. Now we will see that how we are using or representing these components of statistical in the statistical table. First of all, I am saying as earlier that the title which is written in the capital and no small case letter or comma full stop should be used. All the words should be written in capital only, like this as I am writing here. Now the second one is prefatory notes, just written below the title, which is here I am telling prefatory notes, this one. Now next we comes in a box, make box and write first of all box heading, which is here written in here. This is box head. We are writing the main head of the box, that is box head, which is also called column notes. In column we are writing this. We are writing these columns, box head, like this. And then the next one is comes just below in the second column. We are saying row captions, which is explained here. The row captions, which is also called the stub. And the next one is column captions, which is explained by me earlier here. So this is column captions, this. And next is sub entries. This is stub entries, which is written in the row captions. This row captions and stub entries. This stub entry is also called row captions. Now the last is the body. What is written there? The main body part. That what's the topic should be going there. So the body should be written here. And finally the footnotes and source should be written below the box, as writing above the box the title and the prefatory notes. As like that we are writing footnotes and source note just below the box, just below the statistical box. Now come to see that types of tabulation. Types of tabulation. The first is simple tabulation. This is also called one-way tabulation. The next one is double tabulation. We call it as two-way tabulation. Two-way. And the third one is complex tabulation. Now we will understand it one by one, that what is simple tabulation, what is double tabulation, and what is complex tabulation. Now I will tell you what is simple tabulation. Simple tabulation means when the data are tabulated to one characteristics, it is said to be simple tabulation or one-way tabulation. Only we are taking the tabulation of data of only one thing. Like for example, we are taking that tabulation of data on the population of the world, that we are taking the data of population of the whole world, only taking the population, not male, not female, not literacy, nothing, only one population, that numbers of peoples who are living on the world, whole world, only we have to know that only. Tabulation of data on the population of the world classified by one characteristics, like we are taking one characteristic only. The next example I am giving you, like religion, we have to go and take the data of only one religion, only one thing, religion. If anyone is sending them that go in that state, like take example of Delhi, go in Delhi and take the data of religion only, not of the religion of male, not the religion of female, and nothing's data, only the data of religion, that which religion and who belongs to which religion, and nothing else. So this is called simple tabulation or one-way tabulation. Now come to double tabulation. Now come to see double tabulation. It is also called two-way tabulation. I am giving the example population or religion, anything, any one thing, one way. Now they come to see the double tabulation. What is the meaning of double tabulation? Double tabulation, it means we are calling in simple language that when the data tabulated according to two characteristics at a time. At a time we are taking the two characteristics at a time, that going anywhere and taking the two data. One is religion and the another is sex, that which sex belongs to whom. Either they are male, either they are female, or either they are transgender. Only we are taking the two data of that, taking the data of religion or taking the data of sex, one at a time, two data. That is called the double tabulation or two-way tabulation. When the data are tabulated according to two characteristics at a time, एक समय में हम जब दो चीज का डाटा एक साथ लेंगे तो हम उसको डबल टेबुलेशन कहते हैं, या टू वे टेबुलेशन, दोहरा टेबुलेशन उसको इन हिंदी में वी आर कॉलिंग. This is said to be a double tabulation or two-way tabulation. For example, tabulation of a data on the population of world classified by two characteristics like religion and sex. Example of double tabulation. Like when we are going to see two things in the whole world, that is one is religion and one is sex at a time. That go and take the data of a person, that this person belongs to which religion and his sex is what, either the male, female or transgender. Only two data. That is called double tabulation or two-way tabulation. Now comes to see what is complex tabulation. As we all know, complex, it means complex. It is more than one, complex. Simply complex means what? Complex when the data tabulated according to many characteristics, it is said to be a complex tabulation. When we are calculating many things one at a time, many things like sex, education, female, color, caste, height, weight, everything one at a time, then that is called simply a complex tabulation. Now see the example of complex tabulation. I am giving you just like we are taking the tabulation of religion, sex and literacy once at a time. All three should be calculated once at a time. This is called complex tabulation. Now see the example. Tabulation of a data on the population of the world classified by three or more characteristics. Now let's comes to see the next topic, which is cross tabulation. Now we will see what is cross tabulation. First of all, I will give a brief description on cross tabulation. So cross tabulation is basically referred as contingency table or cross tabs. It entails as when a group of variables together enables to understand the correlation between the different variables by showing how correlation change from one group to variable another. Cross tabulation allow for the identification of patterns and probabilities within data sets. Cross tabulation helps you to understand how two different variables are related to each other. For example, suppose you wanted to see if there is a relationship between the gender of the survey. like somewhere survey is going on, and the survey is of gender only, not caste, not anything, only gender. So survey responder, if sex education in high school is important, then they are going to surveying the male and the female or transgender and giving them the sex education. Now see one data of primary survey. What is the source? The source is here is primary survey. Now if just I am taking like items like yes and one is no, and male and female. If in male there are 250 per 140 females, so it is in the item of yes who want to study the sex education, who basically it means that they want to that sex education should be important in the school, in the high schools, like that important. But and the no who was saying candidate in male, 250 males are supporting sex education in high school, and 210 males are not supporting sex education in high school. Now comes to see the female, then we are seeing that females are supporting, only 140 females are supporting yes that sex education should be mandatory in school, but 566 female doesn't want that sex education will not be educate teaching in school. So so crosstab have been various advantages as a tool over other statistical tool. Firstly, they are simple to compute and easy to understand. Secondly, they provide comparatively data on two more variable across multiple features at one glance. In certain case, they may be also help solve the issue of missing data. Further, crosstabs can be used with any type of data, whether it is ordinal, nominal, ratio or interval data. Now see today most computers and companies use data warehousing intensively. In these, the use of software applications like relational database management system can facilitate the cross tabulation of any two data with each other, compare them and spot their correlation. Now as we are seeing that in cross tabulation, there are simply we are making the table. Now tabulation is over. Now we will see descriptive statistics. That what is descriptive statistics basically as we all know that statistics has two branches. One is descriptive statistics and another is inferential statistics. Now first of all we will study descriptive statistics. So while categorizing statistics, we see that the study of statistics can be categorized into two main branches. These branches are descriptive and statistics and inferential statistics, as I am said here. Now, to collect data for any statistical study, a population must first be defined. Population indicates a group that has been designated for gathering data from. The data is information collected from the population. A population is necessary referring to people, and a population could be group of people, measurement of rainfall in particular area or batch of batteries. It means that we are seeing that sometimes population, we are seeing populations categories, a measurement group of peoples. So now comes to see descriptive statistics. In another way, we can say that descriptive statistics gives more information that describes the data in some manner. For example, suppose a pet shop sell cat. Suppose a pet shop who is selling cat, dog, anything, bird, fish. You can take any example of them. If 100 are sold and 40 out of 100 were dogs, then the description of the data on the pets should be 40% were dogs. It means in 100 there are 40 dogs, 30 cats. Same pet shop may conduct a study on number of fish sold each day for 1 month and determine that an average of 10 fish were sold each day. The average of is an example of descriptive statistics. Now see, basically that graphical representation of data has four methods: graphical, central tendency, dispersion and association. I will discuss it further. Some other measurement in descriptive statistics answer questions such as how widely dispersed is this data? Are there a lot of different values? Question arises here. Or many of the values the same? What value is in the middle of this data? Where does a particular data value stand with respect with other values in the data set? Now we are going to discuss all these questions in further. So now listen that a geographical representation of data is another method of descriptive statistics. Example of the visual representation are histogram, bar graph and pie graph. To name a few, using these methods, the data is described by compiling into graph table or other visual representation. So this provides a quick method to make comparison between different data sets and to spot the smallest and largest values and trends or change over a period of time. Time to time it should be changing. If the pet shop owner wanted to know what type of pet was purchased most of the summer, the graph might be good, medium, compared to number of each type of pet and months of the year. Now basically when basically shopkeeper were knowing that which type of pet are selling in summer or winter, they will bring out that type of pet in their shop and they were selling, so the market should be good over there. Now the question arises that there is the following most common techniques of descriptive statistics. Now we will see here. The first one is geographical pictorial methods, and the second one is measures of central tendency, and the third one is measures of dispersion, and the fourth one is measures of association. So finally we will discuss about frequency. That what is frequency? Basically, frequency is a set of data is arranged in order of magnitude. The middle value of the arithmetic mean of the two middle values that divides into the set of into two equal parts is the median. Or by extending this idea, we can think of above those values which drive and divide the set of into four equal parts. These values denoted by Q1, Q2 or Q3 are called first, second and the third quartiles respectively, the value Q2 being equal to the medians. Similarly, the values that divide the data into 10 equal parts are called decile and denoted by D1, D2 and goes on to infinite. While the data of the values dividing the data into 100 equal parts are called percentiles. As we are denoting hundreds, that denoted by P1 and P2 are going to P99 tilth. The fifth decile and the 50th percentile corresponded to the median. The 25th and the 75th percentile correspond to the first and third quartile respectively. Now we will see the parts of frequencies. As first of all we will discuss quartile. That what is quartile? Simply, quartile is basically we understand or we come to know today that what is quartile. So quartile is also known as semi-interquartile range. Here the difference between the third and first quartile is called interquartile range. The interquartile range may be taken a measure of dispersion, that is, it extends to which the values are spread out from the average. Now we will see what is the merits of quartile deviation. It can be easily calculated and simply understood, and it does involve much mathematical difficulties, as it take middle 50% term has been used and to measure better Then range and percentile range. It is not affected by extreme terms, as 25% of upper and 25% of lower terms are left out. And the last one we will discuss, that in case we are to deal with the center half of the series, this is the best measure to use. Now we will see the merit of quartile. Now we will discuss what is the demerit of quartile. As Q1 and Q3 are both pictorial and positional measure, hence are not capable of further algebraic treatment, as like calculation are much more, but result obtained is not much importance. If it is too much affected by fluctuation of sample, and 50% terms play no role, first of last 25% item ignored may be give reliable result. If the value v irregular, then the result is affected badly. We can't. Now we will see the next demerits of quartile. We can't call it a measure of dispersion, as it does not show scatterness around any average. The value of quartile may be same for two or more series of Q T. It is not affected by the distribution of terms between Q1, Q3 or outside their positions. So, going through the merits and demerits, we conclude that quartile deviation cannot be re, re, relied on badly in cases of distribution with the degrees of variation. Quartile deviation has less reliability. Now we will see the next point, that it is decile. That we will study what is decile. Now finally come to know that what is decile. As we all know, basically the decile means the 10th positions of values in this decile. So decile is basically we called as decile. The term decile refers to the 9 values of the split. The population does not into 10 equal we called it as 10 equal fragments, such that each fragment is represented with 1/10 of the population. In other words, each successive decile corresponding to the increase of the 10th points, such as first decile D1 has 10% of the observation below, the second deals with the D2 or 20% of the observation below, and so on forth. Decile and decile ranks are used more often in real life than the classroom. For example, Australia used decile ranks to report draft data. Decile 1 to represent lowest 20%, much below normal, or we call it the that means through are the much normal. In draft we are not in don't occur more than 20% of the time. Deciles are commonly used for college admissions and high school rankings. For example, the chart from we call as about the high school decile ranking for the student body. Now we will see the next point, that what is percentile. Finally, we will come to know what is percentile. As we all know that we will call percentile as 100th value for calculation large number of population. So percentile are the point which divide the set of observation into 100 equal parts. These parts are denoted by P1, P2, P3, or called as goes on P9, T9, and are all called first, second, third to 99 percentile. The percentiles are calculated for a very large number of observations, like workers in factories, and the population is province or countries. Percentiles are usually calculated for applications of percentiles. Percentile scores have a variety of uses. Anytime that a set of data needs to be broken into digestible chunks, percentiles are helpful, or we call as they are often used in interpreted test scores, such as SAT scores on the test taken can be compared to their performance, so that the other student, for example, a student might can score of 90% on an exam. That sound pretty impressive. However, it becomes less so when a score of 90% corresponds to the 20th percentile, meaning only 20% of the class earned a score of 90% or lower. Another example of percentile on the children's growth chart, in addition to give a physical height or weight measurement, pediatrician typically state this information in terms of a percentile score. A percentile is used in the order of compare the height or weight of a child to other children of the same age. This allows for an effective means of comparison so that parents can know if the child's growth is typically or unusual. Now we will see some examples related to them. One, we will see examples of frequencies in quartile. Now we will see the examples of quartile. The question is, find the quartile Q1, Q2, Q3 of the following data. And data should be like 20, 30, 25, 23, 22, 32, 36. Now finally we are saying, first of all we are arranging this data into ascending order from lower to higher. So we are arranging this in ascending order. First of all 20, 22, 23, 25, 30, 32, 36. Finally we will apply the formula. We are putting here Q1 is equals to 1 by 4 into M into N. So 1 by 4 into N. N means what? And it means the total number of observations. And here the total number of observation is 7. See here. I have written here the odd, and this is an odd number. This is an odd number. As we all know that 7 is an odd number, not even. So finally know this, after applying this formula 1 by 4 into N, so we are writing here 1 by 4 into N. N means number of observation, and the number of observation is 7. So we are putting here 7. If we are calculating 1 by 4 into 7, we got 1.75. It means it is nearest to 2. 1.75 is nearest to 2. So Q1 is equals to 2. So finally we will find, now we will see Q1 is equals to 1 by 4 into N. Why we are applying 1 by 4 here? Because we are calculating Q1, the first of the term. So 1 by 4 into N. So 1 by 4 into N. N is equals to number of observation, and the number of observation is 7, which is an odd number. So if you are calculating 1 by 4 into 7, we got 1.75. And Q1 and 1.75 is nearest to 2. So Q1 is equals to 2. So we are seeing here that this 2, it means second position. 2, it means what? It means second position. So second position is what? 22. So we are getting Q1 is equals to 22. Fine. Now come to see Q2. So Q2, if we are finding Q2, then we are applying as 1 by 4 we are applying here Q1 1. So Q2, in Q2 we are applying this 2 here, 2 by 4 into N. So 2 by 4 into N. N is equal, number of observation is 7. So if we are calculating 2 by 4 into 7, we got 3.5. So 3.5, it means it is nearest to 4. 3.5 is nearest to 4. So the fourth term of Q2 is 1, 2, 3 and 4. It is 25. So we are calculating Q2 is equals to 25. Finally, we got two calculation of Q1 and Q2. Q1 is how much? 22, and the Q2 is 25. Now come to Q3. If you are applying Q3, we are putting here 3 by 4 into N. So 3 upon 4. So 3 upon 4 into 7, if you are calculating, we got 5.25. And 5.25 is nearest to 6. Now we will see the sixth term. 1, 2, 3, 4, 5, 6. It is 32. So the finally Q3 is 32. We got all three of the numbers which we are in question. We are finding Q1 is 22. Q2 is what? Q2 is 25. And Q3 is what? So Q3 is 32. So finally we have to calculate all three of this from the question. So finally we will calculate quartile, and the answer is in front of you. Now finally come to the next, we will see the second frequency, decile. So one example on decile, see here, find the decile D1, D5 and D8 of the following data: 20, 30, 25, 23, 22, 32 and 36. First of all, we have to arrange all these in ascending order from smaller number to greater number, like this: 20, 22, 23, 25, 30, 22, 36. Now as we are seeing that here it is decile. Decile, it means of the term tenth. D1 is equals to 1 by 10th into n. So 1 by 10th into n is the number of observation, which is here 7. Finally it is 7. We have to count it: 2, 4, 6, 1, 7. So 1 by 10 into 7 is equals to 0.7. 0.7 is the nearest term of 1. So D1 is equals to 1. And the first term of 1 is 20. So we write D1 is equals to 20. Here we calculate. Now come to second one, D5. D1 we have calculated. Now come to D5. So D5 you have to calculate 5. So 5 by 10, as we have calculated first, then it is 1 by 10. In fifth it is 5 by 10. 5 by 10 into n. 5 by 10 into n is the number of observation, which is 7, which is ours. So 7, if we are calculating this, we got 3.5, and 3.5 is the nearest number to 4. So D5 is equal to 4. So 4. So the fourth series of our term is 1, 2, 3, 4, that is 25. So we calculate D5 is equals to 25. So finally we have to calculate D5 also, D1 and D5. Now one is left, which is D8. Now come to D8. D8 is equals to, as we have said, which we have to calculate, that is in the numerator case, and the lower case is the decile term of 10th. So 8 by 10th into n. 8 by 10th into n is the number of observation, which is 7 odd. So 8 by 10 into 7, it is should be calculated, and the answer should be 5.6, and 5.6 is nearest to 6. So we have to see the sixth term of our series: 1, 2, 3, 4, 5, so that is 32. So 32 is finally D8 is equals to 32. So we calculate D8 also. D8 is equals to 32. So we have to calculate all three of them. The answer is getting D1 is equals to 20, D2 is equals to 25, and D8 is equals to 32. So this is the example of decile. Now come to see the example of percentile. After decile, we will have to discuss percentile here. And the percentile, it means we are knowing that the 100th value of 100. Now the question arises, find the percentile P8, P50 and P85 of the following data, like 20, 30, 25, 23, 22, 32 and 36. Now first of all we have to arrange this data into ascending order. So we have to arrange this data into ascending order, which is smaller. This should be arranged earlier, and then after greater goes on. So after 20, 22, 23, 25, 30, 32 and 36. Now come to see that we have to calculate these three: P8, P50 and P85. So we will have to calculate this. P8, if we are calculating, then the formula is equals to 8 by 100 into n. Why 100? Because it is calculated as percentile. So 8 divided by 100 into n is equals to 8 upon 100 into 7. If we calculating this, we got 0.56. And as we have saying in earlier, in decile and in quartile, that the nearest value of 0.56 is 1. P8, so P8 is equals to 1, and the first value is 20. So we calculate P8 is equals to 20. So P8 will be calculated 20. Now second one is P50. So P50 is equals to 50 upon 100 into n is equals to 50 upon 100 into 7. This should be calculated, and the answer should be 3.5. Now 3.5 is nearest to 4. So P50 is equals to 4, and the fourth term is 1, 2, 3, 4 is 25. So P50 is 25. So P50 also calculated as 25. Now the next one is to calculate P85. So the formula is 85 upon 100 into n is equals to, and there is n is number of observations here. So now total number of observation is 7. 1, 2, 3, 4, 5, 6, 7. Clear? Now 85 upon 100 into n is equals to 85 upon 100, and the n is equal to number of observation is 7. So here we calculate this. When we calculate this one, we got 5.9. It means that it is closer to 6. So P85 is equals to 6. Now we will see which is the sixth term. 1, 2, 3, 4, 5, 6. That is 32. So P85 is 32. We have to calculate P32 also. P85, that is 32. Now we will calculate all of that, and one by one we will understand everything. So